We have just started the topic of combinatorics. First thing we're looking at is factorials, and the first thing we're going to do with factorials is we're going to simplify things by unrolling factorials. Now remember, unrolling factorials is just where we take the factorial we've got and then bring it down. So we know that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 and so on and so forth. So unrolling it means we're just going to take out the 8 and then we've got times 7 factorial and then take out the 8 and the 7 times 6 factorial and so on and so forth. That'll just make it easier when we're doing things like simplifying fractions and stuff like that. So let's have a look at this first example. We've got 10 factorial divided by 7 factorial. Now, the good thing we know is if we had 7 over 7, they would cancel down. You'd get 1 over 1. Okay, so the whole thing is just simplifying fractions. So if we had 7 factorial over 7 factorial, that would also equal 1 over 1. So what we want to do is take this, specifically that bit, and convert it so that we can do that. So what do we got? We're going to have 10 times 9 times 8 times 7 factorial over 7 factorial. So that's going to bring us down. Those two cancel out. We end up with 1. So we're going to have 10 times 9 times 8, which equals 720. That's it. That's what we're doing. We're just taking it and making it so that we can simplify it. So that's one with numbers. Nice and easy. Part B, you've got n plus 2 factorial divided by n minus 1 factorial. So what you've got to think of is, what does n plus 2 factorial mean? So when we're doing these, n is just a number, any number. The number after n would be n plus 1. The number before n would be n minus 1. And the number before that would be n minus 2. Everything makes sense on that? So what we need to do is we need to, and if I want one further, it'd be n plus 2 and so on and so forth, okay? So what we need to do is split this top one up so that we get that. What we're looking for when we're doing these unrolling is we're looking to get a common factor that we can, with the denominator, so that we can simplify it. So let's have a look. We've got n plus 2. So how else can I write that? Well, n plus 2 is going to be, I could write it as n minus 1 times n times n plus 1 times n plus 2. Actually, that's not a good way of writing it. I'm going to redo that. I'm going to go, I'm going to start with n plus 2, because we always start with the bigger one, same as we started with 10 times 9. So that was my bad. N plus 1, so we're working our way down. Then n, and I'll put it in brackets just so we can see it, and then n minus 1 factorial all over n minus 1 factorial. So you can see what we've done. If you think of it in terms of numbers, you've got 10 is the same as 8 plus 2. 9 is the same as 8 plus 1. 7 is the same as n minus 1. So that's all we're really doing. We're just rolling it down until we can, or unrolling it until we can get the common factor. Then we can cancel them out, and we're left with n plus 2, n plus 1, and n is what we're left with, which if we then, we could actually leave it like that. I'll just take it out of the bracket, so we've got that. And we can leave it unexpanded. I hope that one makes sense. All we're doing is unrolling it until we get back to the n minus 1. On this next one, we have got n factorial. So we're looking at n factorial, and we want to get to n minus r factorial. So on this last one, we did numbers. We had plus 2 and minus 1. This time, we don't even have numbers. We've just got r. So the question is, how do we express that? Now, this has got a lot to do with the way we use notation in advanced and extension maths. Okay, when we're doing, say, numbers, I can say, look, here is n. My next one would be n plus 1. Next one would be n plus 2. And we've done that before, mentioned a second ago. Then I can go but. So I normally use 3 dots, 1, 2, 3 for ellipses, and go, I can start off with my sequence of numbers starts at n. Then the next one is n plus 1. The next one is n plus 2. The next one is blah, 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 blah. And then eventually we're going to go up to n plus r. But I would always, by convention, just do the one before that. And that would be n plus r minus 1. I hope that makes some sort of sense so far. Okay, we're talking about just going up the numbers. So we start at n, then n plus 1, then n plus 2, and then there's lots of numbers in between, and then there's n plus r, minus 1, and then n plus r, and that would be my sequence. So I started at n, and I ended at n plus r. And that's the notation we use. I don't know why I did that. I'm going to undo that so I can just leave it there so you can see it. Now, this one, we're obviously doing n minus r. So we're going to do something very, very similar, except we're going the other way. So we start at n, and the good thing is, like this question over here, we're starting at the bigger number and working our way downwards. So we're going to start at n, and so we're descending in numbers, and we're going to get all the way down to n minus r. Okay, r is just some arbitrary number that we don't know about yet. So we're just doing a sequence. So the number after n, or below n, would be n minus 1. The one below that, n minus 2, dot, dot, dot. I normally do 3 and then do dot, 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 because that is enough to show this is what the sequence is doing. I am taking a number, n, and I'm subtracting 1 each time I go down. So I would go n, and the next one would be n minus r plus 1. And the reason for the plus 1 is because it's the next one there before we get to the n minus r. Sorry, back to it. It was just interrupted for a sec, so that's fine. So yeah, so we've got this sequence of n, then n minus 1, n minus 2, all the way through to n minus r plus 1. So that's the one before n minus r, and then n minus r. So that's what we're doing. We're actually separating out, or we're rolling back, and I'll get rid of the commas, and I'll actually just turn them into brackets so that we can see what we're doing. We've actually just separated out or rolled back our numerator so that we have now a common factor. So we've got the n minus r as our common factor. So those now cancel out, and we're left with n minus 1, n minus 2, dot, 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 because there's all these ones in between, n minus r plus 1. And that is what we're left with. So that is the factors that we're left with. Hope that makes a bit of sense. Thanks, guys.